Hi friends, today I'll be explaining Physics May June 2016 paper 42. Question 1 states an object is moving in a straight line at a constant speed. A force is applied to the object. State the possible changes in the motion of the object. So when a force is applied on an object, the object will slow down and the force will change the direction of the object. For example, if the force is acting from the left side of the object, this will slow down the object and then the object will move in the right direction, so force will change the direction of the object. So the final answer will be the object will slow down and the force will change the direction of the object. Question 1b states figure 1.1 shows a skier taking part in a speed competition. The winner of the competition has the highest average speed over the 100-meter section shown in the figure 1.1. The skier starts from the rest and has a constant acceleration. He reaches a speed of 16 meters per second in 16 seconds. Calculate the skier's acceleration. So the formula of acceleration is v minus u divided by t. So at starting, u is the starting speed and v is the final speed. So the starting speed is 0 kilometers per hour, meters per second, and 60 meter per second is the maximum speed that a skier reaches, and then the time it takes for the skier to travel from rest and has a constant acceleration is 16 seconds. So 60 divided by 16 is 3.75 meters per second. So in the answer we will write 3.75 meters per second squared. It's important to write meters per second squared because it states acceleration. So acceleration is in meters per second squared. If you don't write meters per second squared, then 1 mark will be deducted. So question 1b part 2 states over the length of the 100-meter section, the time recorded is 1.85 seconds. Calculate the skier's average speed over the section. So the formula to calculate the speed is equal to distance divided by time. So over here the distance is 100 meters per second and time is 1.85 seconds. So 100 divided by 185 is 54 meters per second. So over here you must write 54 meters per second square. And it's important to write the value which is the meters per second squared, because in previous question I also stated that it's important because without this the mark will be deducted. Part 3 states suggest why the skier bends his body as shown in figure 1.1. Explain your answer. So over here the skier bends his body. Why? Because when the skier bends the air resistance acting on the skier decreases, so the skier moves faster. It also lowers his center of mass. Why? Because when the skier lowers or bends, there's less area on which the air resistance is acting, so this will increase the speed of the skier, and also when he moves downwards there will be a lower center of mass instead of when he was standing the center of mass was higher, so this will increase the speed of the skier. Question 2 states figure 1.2.1 shows the two railway trucks on a track. Truck A of mass 6000 kg is moving at 5 meters per second. It is approaching truck B at mass of 5000 kg which is stationary. Calculate the momentum of truck A. So the momentum of truck A is momentum is equal to mass times velocity. So the mass is 6000 kilograms and the velocity, which is the speed, is 5 meters per second. So 6000 multiplied by 5, which will be 30,000 kilograms per meter second. So the momentum or the final answer will be 30,000 kilograms per meter second. Then part B states Part B states the trucks collide, their buffers compress, and then they bounce off each other, remaining undamaged. After the collision, the truck B has a momentum of 27,000 kilograms per mass per meters per second. Part 1 states determine the impulse applied to truck B. So impulse is percentage change in P, or momentum is equal to impulse. So we will move impulse over here, and percentage change in momentum is 27,000 kilometers per second per meters per second. So the impulse is the same as the momentum, so it is 27,000 kilograms per meter per second. Then in part 2, the trucks are in contact for 0.6 seconds. Calculate the average force on truck B. So we will use impulse, which is I is equal to force time T, which is the time. So we will move F over here because we have to calculate the average force. So F is equal to impulse divided by time, whereas impulse is 27,000 kilograms per meter per second and the time is 0.6 seconds. So this will be 27,000 divided by 0.6, which will be 45,000 newtons. So the average force on truck B is 45,000 newtons, and we have to write newtons in the answer. Question 2, part B, part 3 states calculate the final spread of truck A. So first M1U1, which is the starting mass multiplied by starting velocity of truck B, plus M2U2, which is the starting mass and starting velocity of truck A, is equal to M1V1, which is the starting mass and end mass and end velocity of truck B, plus M2V2, which is the end mass and end velocity of truck A. Then over here is starting off for truck B. Over here we have 5,000 kgs multiplied by zero velocity because the truck B was stationary, then plus 6,000 kg multiplied by 5 meters per second for truck A is equal to 5,000 multiplied by 5.4. So you might be thinking, why, from where we calculated 5.4? So 5.4 is calculated from here. We have the impulse, which is 27,000 kilograms per meter per second. So we will use 27,000 divided by 5,000, which is the mass of truck B, which will be 5.4 meters per second. So the value of truck B after it was hit by truck A is 5.4 meters per second. So 5,000 multiplied by 5.4 meters per second plus the mass of truck A, which is 6,000 kg, multiplied by velocity, which we have to calculate because we have the starting velocity but we don't have the end velocity. So over here 5,000 plus 30,000 is 5,000 multiplied by 0 plus 6,000 multiplied by 5 is 30,000 is equal to 5,000 multiplied by 5.4 is 27,000 plus 6,000 V2. So when we subtract 27 from 30,000, it will be 3,000 is equal to 6,000 V2. Then V2 is 0.5 meters per second. So the speed of truck A after it was hit, or the final speed, was 0.5 meters per second. Question 3 states figure 3.1 shows a cabin used to transport passengers up a hillside. The cabin is attached to a cable which moves horizontally from A to B, then up the hill from B to C. There is an electrical input of energy to the motor which moves the cable. These take place two ticks against types of energy that increases as the cabin moves horizontally at constant speed from A to B. So when the cabin moves from A to B, and then from B to C. From here, first we will, it states to take against the type of energy to increase as the carbon moves horizontally at constant speed. So first is kinetic energy of the carbon, which is wrong because it's not going upwards or it's not going downwards. So there's, it's not coming downwards, so there's no kinetic energy. Then second is gravitational potential energy. This is also wrong because there's no potential energy because the carbon has it did not reach the top point of the electric motor or the pulley. Then gravitational potential energy, this is also wrong, of the cable, which is also wrong because the cable did not reach at the maximum point. Then the energy of the surroundings, yes, internal energy of the surrounding, yes, this is correct. And then the fifth one is internal energy of the wires of the motor, yes, because the energy is being created by the motor to move the wires of the motor. So internal energy of the wires of the motor and internal energy of the surroundings are both correct. So A is the correct. Part 4, answer 4 and answer 5 are both correct for part A. Part B states the carbon and passenger have a total mass of 800 kg. The vertical distance between B and C is 50 meters. Calculate the increase of gravitational potential energy of the carbon and passengers when they move from B to C. So the gravitational potential energy is equal to mass times gravitational potential energy multiplied by height. So the mass is 800 kg multiplied by the gravitational potential energy, which is 10 multiplied by the height, which is 50 meters, which will be 400,000 joules, which is the value that is used to calculate energy. So 400,000 J. Question with 3 parts. C states the carbon then descends back from C to B. The weight of the carbon pulls the cable which rotates the motor. The motor acts as a generator when rotated in this way. Explain the environmental and economic benefit of this arrangement. So what happens is when the carbon moves downward, it pulls the cable and which rotates the motor. So the benefit of this is that the carbon converts its gravitational potential energy into kinetic energy. So the electric motor does not need energy to move the cable. So it has an environmental and economic benefit by keeping environment clean. So this will be the final answer, and the carbon and the final answer again I will read is the carbon converts its gravitational potential energy into kinetic energy, so the electric motor does not need energy to move the cable, so it has an environmental and economic benefit by keeping environment clean. Question 4 states an archaeologist is investigating a shipwreck and discovers a wooden box on the seabed. The dimension of the lid of the box are 1.2 meters by 0.8 meters and the pressure of the atmosphere is 1 multiplied by 10 to the power of 5 pascals. The lid is 50 meters below the surface of the sea. The density of the seawater is 1020 kilograms per meter cube. The pressure, calculate the pressure on the lid of the box due to the seawater. So we have to calculate the pressure that is acting on the lid due to the seawater. So the formula for pressure is P is equal to d density multiplied by gravitational force multiplied by height. So the density is 10.1020 kilograms per meter cube multiplied by the gravitational force, which is 10, multiplied by the depth of the water, which is 15 meters below the sea. So when we multiply these three numbers, which is 153,000 pascals. So 153,000 pascal is acting on the box due to the seawater. That we have to calculate the total pressure on the lid. So we have to calculate the pressure that the atmosphere is putting on the lid and the sea water that is putting the pressure on the lid. So first we will use the pressure that is acting by the sea water, which is 153,000 pascal, plus the atmospheric pressure, which is 100,000, which will be 253,000 pascal. So the total pressure is 253,000 pascals. So question 4 part A part 3 states the downward force that the total pressure produces on the lid. So we have to calculate the force that is acting on the lid. So the pressure that is acting on the lid is 253,000 total pressure, not only the sea water. So 253,000 multiplied by the area of the lid. So they are given in the statement that the dimension of the lid of the box is 1.2 meters by 0.8 meters. So we will multiply 1.2 multiplied by 0.8, which will be 0.96 meters squared. Then we will multiply this 253,000 by 0.96, which will be 242,880 newtons, because force is always calculated in newtons. So 242,880 newtons will be the final answer for 4A part 3. Question 4 part B states the force needed to open the lid is not equal to the value calculated in A3. So just the two reasons for this. The pressure inside the box, because the pressure inside the box will be so high that there might be less pressure needed to open the box, or the pressure might be too low that you need more extra force as needed, but 242,880 newtons to open the lid. So this might be the reason. And then the second reason is the weight of the lid. Maybe the weight of the lid is high or heavy, so it might be difficult. More pressure might be needed to open the lid, or maybe the lid is light, so less pressure force will be needed to open the lid. So first reason is pressure inside the box, and the second reason is the weight of the lid. So question 5 states two pans containing water are placed on the hot plates of an electric cooker as shown in figure 5.1. The hot plates are switched on and the temperature of the water in the pan start to increase. When the temperature of the water is below 100 degrees Celsius, some water is evaporating. At 100 degrees, the water starts to boil and its temperature remains constant. So state whether which pan has the greater rate of evaporation of water when both pans of water are at the same temperature. First is the large pan has a greater rate of evaporation of water because it has a larger area exposed to hot plate. Why? Because the larger pan has a greater surface area that is exposed to the hot plate, so it will be heated. The temperature of the larger pan will increase quickly as compared to smaller pan. So this will be the answer. Large pan has a greater rate of evaporation of water because it has a larger area exposed to the hot plate. Then part B states, apart from the temperature at which it occurs, state how boiling differs from evaporation. So in boiling, bubbles are formed and boiling occurs throughout the liquid. Evaporation only happens at the surface. Why? Because in evaporation, when in large pan, the evaporation will be at a high rate because the large pan has larger surface area exposed to the air, so most bubbles will escape in large pan as compared to small pan. So evaporation will happen at a higher rate. Then question 3 C part I states, when the water is boiling, thermal energy is being supplied to the water at a rate of 920 kilowatts. Explain the effect on the molecules of thermal energy supplied. So the molecules gain kinetic energy, K for kinetic energy, and they move faster and bonds between them break. So this will increase the movement of the water particles in the large pan and small pan. So question 5 part C. Part 2 states the specific latent heat of vaporization of water is 2.3 multiplied by 10 to the power of 6 joules per kilogram. Calculate the mass of the water that boils away in 5 minutes. So E is equal to latent heat of vaporization multiplied by the mass. And here to calculate energy, it is power multiplied by time is equal to latent heat of vaporization multiplied by mass. So we'll keep the mass separate and move the latent heat of vaporization below P times T, which will be M is equal to PT divided by LV. Then we will use M is equal to 920, which is stated in the statement over here. The thermal energy is being supplied to the water at a rate of 920 watts. So 920 multiplied by 300, which is time. So 5 minutes is converted into seconds, which is 5 multiplied by 60 is 300 seconds. So 920 multiplied by 300 divided by 2.3 multiplied by 10 to the power of 6. So the mass of water that boils away in 5 minutes is 0.12 kilograms. So we will write 0.12 kilograms, including the numerical term or the weight or the matter, which is kg. So 0.12 multiplied by kg, 0.12 kg. Question 6a states figure 6.1 shows a protractor superimposed on the path of a ray of light. The light is traveling through glass towards the boundary with air, with the protractor to measure the angle of incidence of the ray of the light at the boundary with the air. So we have to measure angle of incidence. Angle of incidence is means the angle which is measured when the ray is moving from one medium to another medium. So the first medium is the glass. So we will measure the angle of incidence from the incident ray up till 90-degree protractor. So over here, if we closely look, it is at 125 degrees. So 125 minus 90, which is 35 degrees. So in I, angle of incidence is 35 degrees. Question 6 part 2 states the refractive index of the glass is 1.56. Calculate the angle of refraction in the air. So refractive index is n is equal to sine r divided by sine I. So we have to calculate the angle of refraction. So we will move sine r to the left side and we will write r is equal to sine inverse, because we have to exclude sine from r. So sine inverse multiply by sine I, which is sine multiplied by index, which is 35 degrees, multiplied by the refractive index, which is 1.56, which will be 63.5 degrees. So the angle of refraction is 63.5 degrees. Question B states, BI states, state what is meant by critical angle. So critical angle means the angle of incidence in a denser medium at which the angle of refraction is on the boundary of the air and glass over here at the edge of the glass. So this is known as critical angle, and in critical angle, the angle of our refraction is 90 degrees. So this will be critical angle. So 6 part 2 states calculate the critical angle of the light in glass of refractive index of 1.56. So over here n is equal to sine r divided by sine I. So over here we have to calculate index, or the critical angle. So we will use sine inverse is equal to sine r, which is 90, divided by n, which is the refractive index, which is 1.56. So the critical angle or the angle of index is 39.9 degrees. So 39.9 degrees will be the critical angle. Question C states, Figure 6.2 shows a water wave crossing a boundary from shallow water to deep water. Name the process that takes place at a boundary between the shallow water and the deep water. So there are three types of what's this? There are three types of process of water being direction changed. So first is reflection, when the water waves bounce back in the opposite direction. Then there's refraction, in which the water waves change direction, and diffraction, in which only edge of the water waves bend. So over here this is refraction because it changed its direction and now it's moving at a higher speed than in shallow water, so this will be refraction. Then in part 2 it states, tick one box corresponding to the property of the wave that is the same in shallow water as in deep water. What is same in these both? Over here the speed increased, so speed is not the measure which has remained same. Then here speed did not remain same. Then wavelength, over here the wavelength also changed because at first they are smaller distance wavelength, then later on they are larger distance between two waves, so wavelength is also wrong. Then amplitude, here also the amplitude changed from shallow water to deep water, so frequency is the only thing that remains same in both the waves, in original wave in shallow water and in deep water. So the final answer for this will be the frequency. Question 7a states, describe the use of X-rays in security application, include a diagram. So over here we have 3 marks, so you have to write at least 2 sentences. So in first sentence you will write, X-rays are used to find security threats hidden in suitcases and cargo. And then a second application is, X-rays used in security scanners are used to check luggage and suitcases. It's also used to detect metal things like bombs. So these are 3 sentences that you have to write in the question. Question B states, draw a straight line from each wave to the most appropriate speed. So the first one is radio waves in air. So the radio waves have 300 million meters per second, which is 3 times 10 to the power of 8. So we will draw a straight line from here to 300 million meters per second. Then second is ultrasound in air. So the ultrasound in air has 300 meters per second, which is 3 times 3 multiplied by 10 to the power of 2. So I'll draw a line like this. Then in third, X-rays in a vacuum. So the speed for X-rays in a vacuum and radio waves in air, they both have the same speed. So X-rays in a vacuum will also have 300 million meters per second, which is 3 times 10 to the power of 8. Question 8a states, figure 8.1 shows a coil wound around a steel bar that is initially unmagnetized. An appropriate power supply can be connected between the terminals A and B. No other apparatus is available. Describe how the steel bar can be magnetized. First, how the steel bar can be magnetized. Then second is how the steel bar can then be demagnetized. So when magnetizing, a steel bar can be magnetized by passing direct current through the coil. This is how we can magnetize a steel bar. Then how to demagnetize a steel bar. So a steel bar can be demagnetized by passing alternating current through the coil and placing steel bar in east-west direction. In this way, the steel bar will be demagnetized. Question 8b states, figure 8.2 shows a transformer. 240 volts main supply is connected to the primary coil B. The voltage across the secondary coil S is 12 volts. A lamp in the series with a 3 amps fuse is connected to the S. The number of turns in the coil transformer is not shown accurately in figure 8.2. Predict with a suitable calculation whether the fuse blows when there is a current of 0.2 amps in the primary coil. So yes, it blows up because the current in the secondary coil is more than the rated fuse, so the fuse will blow up. So current will not flow through the circuit. So we will calculate the current in the secondary coil. So we will use the formula V1 I1 is equal to V2 I2. So this will be for the primary coil and this will be for the secondary coil. So in primary coil 240 multiplied by 0.2 amps is equal to 12 multiplied by X. So I2 is equal to 240 multiplied by 0.2 divided by 12, which will be 4 amps. As 4 amps is greater than 3 amps fuse in the lamp, then absolutely correct. Yes, the lamp will blow up. So yes, it blows up because the current in the secondary coil is more than the rated fuse, so the fuse will blow up. So current will not flow through the circuit. Question 9 states figure 9.1 shows a conducting ball that oscillates between two charged plates. The ball repeatedly strikes each plate in turn. Explain in terms of the charge of the ball on the ball why the ball moves to the positive plate after striking the negative plate. So the answer for this question is due to striking ball gets negative charge from the negative plate. Now it will be repelled from the negative plate and is attracted towards the positive plate. Opposite charges attract each other. So when the ball hits the negative plate while it's positively charged, it becomes negatively charged from the negative plate and then it's repelled from negative plate towards the positive plate and it's attracted to the positive plate. So in this way, the protons and electrons are being transferred from the ball to the plate and then from the plate to the balls continuously. So the ball moves from to the positive plate after striking the negative plates. Question B states which particles move through the sensitive ammeter and the direction in which they move. The electrons will move from L, which is left to right, which is right. So electrons will move from left to right. Question 9c states for each complete oscillation of the ball moving between the plates, a charge of 8.5 times 10 to the power of minus 10 coulombs, which is the Q, is transferred from one plate to the other. The frequency of the oscillation is 4 Hz. Calculate the current shown in the sensitive ammeter. So Q is the charge, which is Q is equal to IT. I is for current and T is the time. So we will calculate I, which is I is equal to Q divided by Q divided by T. So for T, it is 8.5 multiplied by 10 to the power of minus 10 divided by 40.25. How? Because it states moving between the plate, charge of 8.5 multiplied by 10 to the power of minus 10 coulomb is transferred from one plate to another. The frequency is 4 Hz. So to calculate time, we will use T is equal to 1 divided by 4 because in every second there are 4 Hz. So we will calculate 0.255, which is the time that it takes for the sensitive emitter to move from one side to the other. So we will write 8.5 multiplied by 10 to the power of 10 divided by 0.25, which will be 3.4 multiplied by 10 to the power of 9 amps. So the current will be 3.4 multiplied by 10 to the power of minus 9 amps. Question 10 states figure 10.1 shows part of the circuit of a hair dryer with 240 watts AC supply. The switch can be in one of the three positions. Position A is off, then position B is low heater power, and position C is high heater power. All three heaters X, Y, and Z each have a power of 1000 watts. When used in this hair dryer, heaters Y and Z have equal resistance. So first we have in part A, we have to calculate the resistance of heater X. So P is equal to VI. So first we have to calculate the current, which is I is equal to P divided by V. So the power is 1000 watts divided by 240 volts is equal to 4.17 current, which is amps. Then we will switch with the formula, which is V is equal to IR to resistance, because we have to calculate the resistance of heater X. So R is equal to V divided by I. V is 240 divided by I 4.17, which is 57.6 ohms. So the resistance of heater X is 57.6 ohms. Question B states calculate the resistance of heater Y. So as there are two heaters which have same equal resistance, so we will use V squared, because there are two heaters and each will be using half the voltage. So if the total voltage is 240 volts, we will divide 240 by 2, which will be 120 for each. For Y 120 volts and for Z 120 volts. So we write P is equal to VR, V squared divided by R is equal to 120 squared divided by X. So we'll move X is equal to 120 squared divided by 1000 watts, which will be 14 ohms. So the resistance is 14 ohms. So 10C states the current in heater Z when the switch is in position C. So we have to calculate the current in heater Z. So first we have the voltage, which is over here 240 watts, and then power is 2000, what's this, over here 2000 watts, and then we have to calculate the current, which is X. So P is equal to VI. So we will use I is equal to P divided by V. P is 2000 watts divided by volts, which is 240, which will be 8.33 amps. So the current in heater Z when the switch is in position C will be 8.33 amps. Question 11 states radon 220 is a radioactive isotope. Part A states the nuclide nutation for radon 220 is 22086Rn. Describe the composition of neutral atom of radon 220. So we will put the numbers of each of the electrons, nucleus, and nucleons. So neutrons. So first we will calculate the electrons, as protons and electrons are same. So 86 electrons in the nucleus, then 136 neutrons in the nucleus, and then 86 electrons in the shells or in the orbits around the nucleus. So these will be the three sentences that you have to write to get 2 marks. Question B states the nucleus of radon 220 decays to an isotope of protium by emitting an alpha particle. Question 11b states a nucleus of radon-220 decays to an isotope of polonium by emitting an alpha particle. Complete the nuclide equation for the decay of radon-220. So in alpha particle we have 2 protons and 2 neutrons and 2 electrons. So over here we will write 2, and then in total number of our neutrons and protons is 4. So you write 4 and 2 plus polonium, which is 220 minus 4, which will be 216, and 86 minus 2, which will be 84. So alpha particle will have 4 our total number of our protons and neutrons and 2 protons, whereas in polonium we have 216 total number of protons and neutrons and 86 protons. Then in question C states a detection of radiation is placed near a sample of radon and gives a reading of 720 counts. The half-life of radon 220 is 55 seconds. Calculate the reading after 220 seconds. Ignore the background radiation. So at starting 720 counts, we have 0 reading. At 0 seconds, we have 720 counts per second. I was confusing you. So 0 seconds, at 0 seconds, we have 720 counts per second. Then at 55 seconds, we have the half-life, which is 720 divided by 2, which is 360. Then after 110 seconds, which is double of 55 seconds. 110 seconds we have 180, which is 360 divided by 180. Then when we double this, when we add 55 into this, which will be 165, the half-life will be 180 divided by 2, which will be 90. Then when we add 55 seconds into 165, which will be 220, then at 220 seconds we will have 45 counts per second. So what we have to calculate a reading after 220 seconds. Ignore background radiation. So the reading at 220 seconds will be 45 counts per second, which is very important. So I just wanted to tell you guys that in every question where there is where we have to calculate the numbers, you have to write these units in every answer, because without units you will get -1 or -2 marks. So this is important to write units.